Now we will listen to Daniela Tomova. So she studied management information systems in the US and has worked in London, then before migrating to Norway, where she's currently. And she has 18 years of experience with analytics, data engineering, and metadata systems, and is currently working as a chief consultant, specializing in analytics strategy and cybersecurity at Atea Norge AS. And she's also a fantasy writer. I have to say that I'm very impressed by that. So once again, please note that we welcome questions in the chat. I will, as you saw, join this conference again at the end, when it's time to wrap up the presentation. And we will once again spend a few minutes at the end of the presentation to discuss these questions. Please, Daniela, take it away. Okay, I can't see you yet. Are you with us, Daniela?
Can you hear me now? Hello?
Oh, that's perfect.
Okay, great. You can hear me?
I can hear you and I can see you.
Okay, great. Let me share my...
Oh, this is perfect. So I will leave this digital or virtual room in the meantime and hand over the presentation to you.
Okay, so can you just confirm that you can hear me and you can see the presentation right now?
See the presentation and I can see you and hear. And it looks
okay. Great, thank you. I cannot see the questions in the chat, so if there's anything, I will answer them afterwards. Okay, so hi. I can only see my presentation right now, so hope my face is actually responsive enough. But I'm Daniela Tomova. I come from Bulgaria originally, but I went to study in the US, and then I moved to the UK and then to Norway quite a few years ago. So I've been living in Norway ever since. I just got citizenship, so yay. Okay, so I was born in the 1980s, and I'm a huge nerd forever and ever. So I was born before the fall of the Berlin Wall, so I am one of those. I'm an elder millennial. I was mostly running around and playing with some dogs and books. I read a lot, and I learned everything that I knew about the world from different stories. So I still make sense of the world through stories. And that's I make sense of my own self through stories, which is why I write. Stories are the oldest form of data sharing. You learn everything from stories that your parents told you, and people, as far as there have been people, have learned from each other through stories and fairy tales. And we think, perceive, and remember in terms of stories. Our actual own brain is the most complex system known to humanity. And it is very, very much biased in favor of stories. It constantly writes and rewrites our own personal story based on what happens to us and how we behave. And stories allow us to communicate abstract ideas through context and parallels. And the reason why I have this slide right now, which is not completely related to my overall idea of the presentation, is that knowing how to tell a story about technology is a superpower. And this is kind of part of the reason why I have a career, mostly because I studied management information systems, but I could have been just a general business person, gone into management. Sorry for all of you managers, but I dread that. but my ability to be able to communicate both to the technical people and to management and to clients and internally was actually what made me kind of like this connective tissue and got me into data. So what is a story? A story is just data, but told in terms of cause and effect throughout a timeline. As data people, you all probably know how this works. So yeah, I studied management information systems in the US, and then I worked as a campaign analyst, not political campaign analyst, but advertising campaign analyst. So then I moved around quite a bit, and then I found my place in Norway because I'm an introvert. And I like my space, and I love nature. So I moved to Norway with a job. I found a job first, and I was hired to develop a data feed for commodity data starting from scratch. Speaking of the previous presentation, I was a product manager for a data feed, and that started in 2008, basically. So at that time, there wasn't much. I just found my own path. There wasn't much information about what to do, how to build feeds out there. So I had a bit of a rough start. I was hired into Point Carbon, which was a Norwegian startup for power, gas, and carbon analytics, mostly based on weather data. And if any of you have worked with weather data, it is extremely large and complex. But it is very understandable if you kind of take it apart in the way that I described in that presentation. Most of our data available when I was hired was in personal Excel spreadsheets, or it was scraped into some central database no one could make sense of. The feed team, which was the person who hired me, who was more of like the salesperson, and myself, we started selling data set by data set if somebody wanted some of the analytics data. And then in 2008, there was a couple of legislation. This should be actually legislations. It kind of were accepted and went into power, and then there was a lot of data out there. It's huge. So suddenly there were millions of sets. So any local or national, international gas, electricity, everything provider was forced to publish their data, the entire stack. So what their consumption is, what they do, how they produce the data, what kind of forecast they have on production of data, et cetera, millions of data sets. And then all of a sudden, of course, once something new comes up, people figure out how to make money of that, right? So there were many traders and trading companies popped up, quite a bit of them in the Nordics. I remember going to Denmark. I remember talking to Danish people every single day of my life for 10 years because there was lots of trading in Denmark, there was lots of trading in Sweden, and not so much in Norway. And then we opened up towards Europe and then the US, and then we were purchased by Thomson Reuters, which is a big company, and it just opened up. So we were a team of 2, then we hired a few more, 4, max 5 people, and we were supposed to make that happen. How does it happen? You have millions of sets, you have terabytes and terabytes of data constantly coming up, and the problem was that the providers they had absolutely no interest in making our lives easier for us. They were forced to publish the data, but they were going to publish it in any damn way that they wanted to. So how was our tiny little sad team supposed to make that happen? So having data in Excel spreadsheets and custom databases was no longer an option. Complexity of the data was no longer an option, and custom solutions were for usage of the data were no longer an option because we had clients, we had paying clients. So how did we actually build the data feed off the backs of the brains of like 4 people? So we normalized everything. We didn't come up with this. The company, we worked with some very, very smart people. We were working with like, PhDs in mathematics and physics and nuclear physics and so on. So basically, how the company was storing the vast majority of commodity and weather data. Any data that you can think of commodity-wise, it could be stored in these 3 to 4 different fields. So you had the unique curve ID, which was the unique ID for this data, for this piece of data. Then you had the forecast date if you were working with forecasts, and you had the value date, the date for which the value refers to, and you had the value. Okay, so on the side of that, so this was stored as a data and big data tables. And the reason that we wanted to separate that from the metadata is that the metadata is more or less static, whereas the variable data itself is the one that took most space. I'm looking at the time I have. So the variable data was the one that was constantly kind of coming up, whereas the metadata could be separated out of that and then linked via a curve ID. So this our centrally maintained metadata system, which was basically huge beast that I didn't start it, but I inherited a tiny little kernel of that, and I built it to actually encompass every single piece of data that we had, with the help of course of the team. But I was the one going to the analysts and just forcing them. I was not very well liked by the smart people, because I was the one forcing them to tag their curves, to create metadata, to use the metadata. That was 10 years of my life, but I'm quite proud of it, because if you look up Point Connect, which was my feed, today it's still there. It was bought, the company was bought by the London Stock Exchange group, but it's still there and it's still used the exact same way. So the metadata system in itself was in the form of tuples. So you had the curve ID, which was the unique identifier, and then you had different categories. So you had commodity, provider, variable, geography, value, frequency, etc. And then linked to that was a verb, which is the relationship. So geography is if it's referring to a specific location, or geography from and geography to if you're referring to a direction, and so on. And then you had the value. The value was out of a specific list. So for geography, for example, we had lists of countries, we had lists of NUTS2 regions, we had lists of rivers, and every kind of discrete geographical notion that you could use. And then this was all linked to the unique curve ID. So if somebody wanted to use the data itself, this data, the normalized data, you could link it up to the metadata and understand exactly what you're working with. This was also usable because you could basically search for data on the basis of its metadata, and you can aggregate it. So for example, if you wanted a total list of of power stations in Norway, you could aggregate it based on, you would just look for geography in Norway, and then you pick up all these curves and you aggregate them. So I made up this types of metadata. It's kind of old, but there are different kinds of metadata. If you search online about types of metadata, you'll find different categories. This is very much geared towards commodity data. So you had the different descriptor types. So you have the computational. They describe the form of the data. Is it a forecast? Is it an actual? Is it synthetic, and so on, or the unit of the data? Then you had the mechanical, which described how the data behaves. You had to actually look at few days or weeks of data to understand. Issue frequency basically refers to how often the data is created, and so on. And then you had the semantic. So those are more qualitative descriptors. So you had the semantic, which describes the data itself, and then situational, which is kind of more real world context of the data. So then we use the metadata to search and retrieve anything that we needed to, and then the beautiful thing about that is that the taxonomy that we created out of this was used to store institutional knowledge. So for example, if you had somebody who had in-depth knowledge of the power stack of production facilities in Norway, they would create a metadata model that you could tag curves with based off their knowledge, and that would describe the relationship between the different parts of the power stack inside this data model. So it was very valuable, and I still use metadata to metadata and models to store institutional knowledge. Another key thing was we store the data as close to raw as possible, because you don't really want people being in your data stream. So you store it as close to the way you found it as possible. So it's much easier to verify and quality check against the, I guess, outside sources or inside sources, or you wouldn't lose any detail to the data if somebody decides to aggregate it. So, and the other valuable part that we learned is don't create your own standard if there is a good one out there. We use a lot of ISO standards. I still can quote the main ones, like the geography ones and the time zones. So you don't have to maintain them. The knowledge is crowdsourced. They're well documented. People that you are working with, who are going to be working with your data, are usually familiar with those standards, or they can find the documentation outside. You are no longer holding the hand of the data users. I can tell you, I have been kind of people's. If you have the data, people are gonna start kind of depending on you, and that takes you to very scary places where people are just like complaining to you and using you as their psychiatrist. So yeah, again, minimal maintenance. 80% of our time was already spent on the internal metadata maintenance. So if you can skip on the maintenance by using standards, by all means. So timestamps, very important. Speaking of storing the raw data, I can count on my hands the number of people that are aware of the different details about timestamps, because the timestamp that you're looking at when you're working with the data can be created at very different points of when the data was created. So you have timestamp which is registered when the value was actually generated. Timestamp created when the data is stored in the database. That's a very different time. When the batch is stored, if data is batched and then stored or parsed, those are different timestamps that you need to be aware of when exactly the event happened that the data describes, or when the data was parsed by a secondary tool. Time zones are important. Yeah, I won't go into this, but if you ever need to, if you're ever in doubt, use UTC time zone. So how does this translate to non-commodity data? Does it translate to non-commodity data? So this is my cat. He is a very good Splunker because he's worked with me for many years. So metadata, I'm going to harp on this. Metadata is more useful than people realize. Metadata varies as well, and the variable part of the data is not everything that you need to look at and pay attention to and understand. So creating taxonomies out of your metadata, again, allows you to normalize, enrich, search, and document your data. It means that you have to store way less data than if you were storing everything together. It also allows you to store institutional knowledge and create dynamic documentation, create models of the data itself. But if you most importantly, if you distill the variable data from its metadata, you can understand the behavior of real-world entities. So, for example, there are bad ways to do this and good ways to do this, but here's a link. If you just look at usage of metadata for surveillance, for example, telco traffic is regularly used by governments to survey behavior of people. So more examples from cybersecurity, because I have kind of transitioned into that, because if you work with Splunk and data these days, it's very difficult not to transition to cybersecurity. So you have network traffic metadata. It can be used to discover DDoS attacks, random adversary activity, figure out what the adversaries are doing. You can track exfiltration of data. You can track medication abuse and theft, patient safety, incidents, and anomalous behaviors, not just employees, but everyone, etc., etc. There's countless examples. Mostly cybersecurity people are working with the metadata itself. Again, real-life data is messy and often uncontrollable. The good thing about Splunk is that we get to be exposed to that, and you get to find out a lot more than if you had very, very sterile variable data. Cybersecurity is a very rapidly growing field. And then, metadata can be used as a tool to understand both the story and the relationships in the data if you know how to look. You can reveal the hidden shapes in your data without even looking at the values, and I will show you how you can do this. It is right now, most of my work with analytics is mostly working on the metadata itself. What kind of events happen at what time, what is the relationship between these events, how these events how different systems interact with each other. All of that is mostly ignoring the core variable data and just looks at the metadata. So R&D is a little bit of a generous name for it, but I'm working on metadata analytics. This is Splunk, but it can be done in any tool that you want. So if you look at this, for example, these you have this one event, and then you have a second event here, and then Splunk gives me very easily what's the word? The different metadata fields. The thing on the left-hand side is basically mostly my metadata fields. And I do analytics, I analyze, I extract, for example, categorical data. So if you see here, this is all the metadata that I have for these events that have been registered by this Suricata tool. And then I can extract the different categories. So basically a category, the way I've defined it is a field that occurs in almost all different events, but the distinct number of values is less than like maybe 10. So that tells me that it's a categorical data. I can go into more detail if anyone is curious, but basically I have this count is how many times this field has appeared into my results, and distinct count gives me the different distinct values inside all these times that this field has occurred. And if the distinct count is limited, if it's just a handful of different values, that is a pretty good indicator that this is categorical data. These are different categories. And I'm kind of running out of time, but I'll finish with this. I do basically most of my work right now when I have time and I'm not with a client is I do metadata analytics. I'm trying to describe or discover different relationships in the data through its metadata and how it relates to each other. Yeah. Okay, I am not. I could go into this if anyone wants to ever contact me on LinkedIn, or I can give you my Discord. And of course, I have a couple of presentation on this specific research that I have on metadata analytics and what I do more with the with analytics and analyzing and discovering shapes in the data. So if anyone is curious, just contact me. And I hope this was helpful. I tried to share my experience of what works, what has worked for me. And if there's anything I can stress on is that metadata is very important. Don't discount it, especially if you are a student right now. You might be familiar with the more sterile data from your labs, but real life data is different. So the sooner you get your hands dirty, the better. Yeah. Okay, that's me.
Thank you so much, Daniela. This was really, really interesting. We will have time for one question before going for a short coffee break. Is there anyone who wants to write something in the chat? Because if not, once again, I wrote down several questions. I think this is really, really interesting. It's also tricky. I mean, metadata is a sector that's important, but as you said or mentioned, normally people think about the core value data, right? So, okay, suppose then that I am a student now. I can even be someone that has worked with data, but not metadata. I mean, how could I start thinking about these things? Are there maybe projects online that I can look into? How can I force myself to start learning about this subject and start exploring it?
So mostly mostly if you get into, again, data governance, you will have to be exposed with metadata. You have to be exposed to metadata. The one way that you learn is there has been a lot more things out there recently in the last few years. So if you just Google metadata education or something like this, you could do this. But sorry, I just thought of something. The way to do this is to work with the data, get your hands dirty, and yeah, because these things I've been asked, where do I read about this, and I don't know actually. Mostly it's about working with it and exploring and trying to find out what happens. Just move back and forth, or I can do you one better. I can collect a list of sources and places that I can share with you after
wow.
this.
Yes,
If anyone's
please.
interested.
That
Yeah.
would be absolutely brilliant.